Module 13 Wireless LAN Configuration. Okay, so in this module, it will explain and regarding implementation, wireless LAN using wireless router and wireless LAN controller, okay, WLC. So in this topic, we have subtopic regarding remote site wireless LAN configuration, which is it will explain about configuring a wireless LAN to support a remote site. And next, configure a basic LAN on the WAC or wireless LAN controller. So this also will teach you how to configure a wireless LAN controller, wireless LAN to use the management interface and WPA PSK authentication. And next, configure a WPA2 or version 2 enterprise for wireless LAN on the wireless LAN controller, which is it will teach you how to configure a wireless LAN controller on wireless LAN to use a VLAN interface, DHCP server, and WPA version 2 enterprise authentication. And then finally, or the final topic regarding troubleshoot wireless LAN issue. So it will teach on a troubleshoot step, okay, for the common wireless configuration issue. 13.1 remote site wireless LAN configuration. Okay, this video, if you get from the NetAcad, it will cover about use the wireless router web page, change the password, change the wireless one, and also LAN setting, and finally connect the wireless network. Please get this video from our NetAcad. Yeah. All right. So this regarding wireless router. So remote workers, small branch offices, home networks often use small office and home router. These integrated routers typically include a switch for wired client, a port for internet connection, sometimes labeled WAN or WAN, and wireless component for wireless client access. This wireless router typically provide wireless LAN security, DHCP services, integrated name address translation or NAT, quality of service QoS, as well as a variety of other features. The feature will vary based on the router model. Note, cable or DSL modem configuration is usually done by the service provider's representative either on site or remotely. Okay, log in to the wireless LAN. Most wireless routers are pre-configured to be connected to the network and provide wireless. Wireless router default IP addresses, users' names, and password can easily be found on the internet. Therefore, your first priority should be to change these defaults for security reason. To gain access to the wireless router configuration GUI, open your browser and enter the default address for your wireless router. The default address can be found in the documentation that came with the wireless router, or you can search the internet. The word admin is commonly used as the default username and password. Okay, basic network setup. Basic network setup includes the following steps. First, log in to the router from a web browser. Next, change the default administrative password. Log in the new administrative password. Change the default DHCP IPv4 addresses. Renew the IP address and log in to the router with the new IP address. So these are basic network setup. So basic wireless setup. Basic wireless setup include the following steps. First, view the wireless LAN default, change the network mode, identify which 802.11 standard is to be implemented, configure SSID, configure the channel, ensuring that there are no overlapping channels in use, configure the security mode, selecting from open, WPA, WPA2 personal, WPA2 as enterprise, etc. And then configure the passphrase as required for the selected security mode. Configure a wireless mesh. In a small office or home network, one wireless router may suffice to provide wireless access to all the client. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoor, you can create wireless mesh. Create the mesh by adding access point with the same setting except using different channel to prevent interference. Extending a wireless LAN in a small office or home has become increasingly easier. Manufacturers have made creating a wireless mesh network WMN simple through smartphone apps. Not for IPv4. Typically, the wireless router is assigned in publicly routable address by the SP and use a private network address for addressing on the LAN. To allow a host on the LAN to communicate with the outside world, the router will use a process called NAT, or Network Address Translation. NAT translates a private local source IPv4 address to a public global address. The process is reversed for incoming packet. So NAT makes sharing one public IP address possible by tracking the source port numbers for every session established by a service. If your ISP has IPv4 enabled, you will see a unique IPv6 address for each your devices. So quality of service, or QoS. Many wireless routers have an option for configuring quality of service. By configuring quality of service, you can guarantee that certain traffic such as voice, video are prioritized over traffic that is not as time sensitive, such as email and web browsing. On some wireless router, traffic can also be prioritized on specific port. Port forwarding. Wireless router typically block TCP and UDP port to prevent unauthorized access in and out of a LAN. However, there are situations where specific port must be open so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. Packet tracer. So this is packet tracer exercises. It will cover, regarding connect to the wireless, configure wireless, connect a wired device to the wireless, connect a wireless device to a wireless router, add AP to the network to extend wireless coverage, and finally update default router setting. You can have this from our NetAcad website. Please do that. And also in this slide, you will configure basic setting on wireless router and connect a PC to router wirelessly. Yeah. So you can use this also to configure physically, your wireless network. All right. You can have this kind of the lab also from our NetAcad. 3.2, configure a basic wireless LAN on the WAC or wireless LAN controller. Okay, video. This video regarding configuring a basic wireless LAN on the wireless LAN controller. Yeah.
Area network on our Cisco wireless LAN controller. This is great. Hello everyone, we are here to configure a basic wireless local area network on our Cisco wireless LAN controller. This is great. The Cisco Wireless LAN Controller, or WLC, is an amazing box that allows you to have a centralized location for configuring multiple access points and deploying multiple wireless local area networks. So let's take a look at our topology. We've got a Cisco Wireless LAN Controller off of switch 1. We have a trunk connection to carry multiple VLANs. Why would we want multiple VLANs between the switch and a wireless LAN controller? Because we're going to have one VLAN segmenting our management network. The management network is how we're going to configure the wireless LAN controller, as well as how we will communicate with our Cisco access points. Secondly, we need another network which is going to connect the user traffic from the access points to the wireless LAN controller. And this is the users on the network, their traffic. So we will see these trunk connections in between our switch and the wireless LAN controller, and then even switch into our access points to allow multiple networks to exist and be segmented on those cables. We then have router R1 over here on the left side, which also has a trunk connection, because router R1 is going to be doing inter-VLAN routing and routing between multiple VLANs, which are networks, between itself down to the rest of the topology. Also, if we take a close look, we'll see there's going to be a wireless client connected off of access point 1. Access point 1 has a link with PoE marked on it. That is power over Ethernet. Access point 1 is being powered by the switch 1 itself on port FA01. We're going to get started here. We're going to be using PCB on VLAN 1, the management network, to communicate with the wireless LAN controller and to configure it using a GUI. Let's get started. Here on PCB, we've opened a web browser, and we've targeted the 192.168.200.254, which is the management IP address of the wireless LAN controller. We are crossing the switch from PCB on VLAN 1 and connecting with this wireless LAN controller so we can configure it on the management network. Since we've accessed the control already on this web page, we're going to click Login, and we'll be asked for credentials. With the credentials, we're going to have a username of admin, and then we're going to have a password of Cisco123 with a capital C. I'll click Sign In, and we'll successfully authenticate, and here is our main splash page on the Cisco Wireless LAN controller. Right now you can see that we have no wireless networks deployed. We've configured 0 wireless networks, so any access points that are joined with this controller, they have no wireless networks to share with users. We can see that one access point has joined, that is the Cisco access point of AP1 sitting on that topology screen. At this time we have 0 active clients. Nobody has joined our wireless networks because we don't have any wireless networks. So let's make one. Let's create a basic wireless local area network. So to get started, I'm going to click on Advanced. We're jumping right in. When I click on Advanced, we're going to get an overview screen of my Cisco Wireless LAN controller. Here it is. You can see that we have one port plugged in, just one. That one green physical port has multiple networks because of our VLANs. We have VLAN 1, which is for management, which we're using right now on this green port. And we have VLAN 5, which is going to be for user data traffic, also on this green port. That is done through what are called VLAN interfaces. VLAN 1 has its own VLAN interface, and VLAN 5 has its own VLAN interface. Top wireless local area networks. It's empty. We've got none right here. So let's get started and make one. I'll go ahead and click on wireless local area networks. Inside of here, there's none listed. So with a drop-down set of create new, we will click go and let's make one. For the profile name, I'd like to name it something like wireless_LAN. And for the actual wireless SSID that the users will see, I want to keep it the same, wireless_LAN. The ID is for me to keep myself organized. I'll leave it at the original ID of 1. When I click apply, we are not done. We have just begun. After it loads, we will see here that we have many settings to choose from for our wireless_LAN profile. We can see this is a wireless local area network. the SSID of what the users will see. We should probably turn on this wireless. That's the enabled checkbox. Let's turn on the wireless so the users can connect. We have something called interface group. Right now it's set to management. That is the management network. I don't want users connecting to the SSID of wireless_LAN and jumping on the management network where they can access and configure the controller as well as the access points. Instead, we'll select the other network that's deployed, which is user_WLAN. This would be the user traffic, which is kept separate from the management traffic. That would be the equivalent of VLAN 5. We're not done yet. Let's go into the security tab and actually put a wireless password on that users will have to use in order to get on the network. We'll leave the default security of WPA and WPA2. We will leave WPA2 policy with AES. That's beautiful. But for the authentication key, I'm going to deselect 802.1x, and I want to use pre-shared key, which is PSK. I'll checkmark PSK, and it's going to ask me what password will you have the users type in. And for me, that's Cisco123 with a capital C. That's what the users will need to enter in order to gain access to my wireless. I'll click apply because we are done at this time for a basic wireless local area network. And then we're going to go back to the main home screen and verify that there is a wireless network, that users can see it, and that maybe a client has connected. So I'll click on home in the top right corner. And where before we had 0 wireless networks and 1. Where there was 0 active clients, there is now 1. I can click on that active client and we can get more info about it. I can see the client's MAC address. The client has an IP address of 5.2, which is on the user network. Management network was 200. The user network is network 5.0. The client joined on the user network, and they joined on access point 1 using my WLAN profile of wireless_LAN on the wireless network name of wireless_LAN that the user saw. We have successful connectivity by deploying network settings and wireless settings on a controller and having the controller share it with the access points.
All right. Okay, that's regarding video configuring a basic wireless LAN on wireless LAN controller. Yeah. Okay, wireless LAN controller topology. Okay, the topology and addressing scheme used for this topic are shown in the figure, this, and the table below here. Yeah. Okay, the access point, which is AP, yeah, is a controller-based AP as opposed to an autonomous AP. So it requires no additional configuration and is often called lightweight APA or LAP, lightweight AP. LAP, yeah, use a lightweight access point protocol, which is LWAPP, to communicate with the wireless LAN, yeah, wireless LAN controller, WLC. Okay, controller-based AP are useful in situation where many APs are required in the network. As more AP are added, each AP is automatically configured and managed by the wireless LAN controller or WLC. Log into WLC. Configuring a wireless LAN controller or WLC is not that much different from configuring a wireless router. The WLC controller AP provides more services and management capabilities. The user logs into the WLC wireless LAN controller using credentials that were configured during initial setup. So the network summary page is a dashboard that provides a quick overview of configured wireless network, associated access point, AP, and active client. You can also see the number of route access point and client. Yeah. view AP information. So click AP or access point from the left menu, yeah, which is highlighted in here, all right, to view an overall picture of the AP system information and performance. The AP is using a IP address 192.168.200.3. Because Cisco Delivery Protocol, yeah, CDP is active on this network, so WLC or wireless LAN controller knows that AP is connected to the fast internet 0/1 port on the switch. This AP in the topology is a Cisco Aeronet, yeah, 1815i, which means you can use the command line and limited set of familiar iOS commands. Advanced setting. Most WLC will come with some basic setting and menu that user can quickly access to implement a variety of common configuration. However, as a network admin or administrators, you will typically access the advanced settings. For Cisco 3504 wireless controller, click advanced in the upper right. Yeah, click advanced in upper right. Yeah, on the upper right corner to access the advanced summary page. From here, you can access all the feature of the WLC or wireless LAN controller. Configure a wireless LAN. Wireless LAN controller have layer 2 switch port. Sorry, and virtual interfaces that are created in software and are very similar to VLAN interfaces. Each physical port can support many AP and also wireless LANs. The port on the WLC wireless LAN controller are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple AP. So each AP access point can support multiple wireless LAN. Basic wireless LAN configuration on the wireless LAN controller includes the following steps. First, create VLAN. Apply and enable VLAN. Select the interface, secure it, verify it is operational, monitor the LAN, wireless LAN, and finally view wireless client information. All right, configure a wireless LAN. Create a wireless LAN. In the figure, a new wireless LAN with an SSID name wireless LAN is created. So next, apply and enable the wireless LAN. Next, wireless LAN is enabled, the wireless setting are configured. So next, select the interface. So the interface that will carry the wireless traffic must be selected. Next, secure the wireless LAN. The security tab is used to access all the available options for securing the LAN. So 5, verify the wireless LAN is operational. The wireless LAN menu on the left is used to view the newly configured wireless LAN and its settings. Next, monitor wireless LAN. The monitor tab is used to access the advanced summary page and confirm that wireless LAN now has one client using its services. Yeah. All right. So next, view wireless LAN client detail. Click client in the left menu to view more information about the clients connected to the wireless LAN. So this packet tracer will teach how to configure a basic wireless LAN on wireless LAN controller. Okay, you can have these exercises in NetAcad. All right. 13.3 configure WPA2 enterprise wireless LAN on wireless LAN controller. So this video will define an SNMP and radius server on the wireless LAN controller.
Hello everyone, we are here to do some management with our Cisco wireless LAN controller. This management is about SNMP and Radius. Why do we use these? Well, let's start with SNMP. SNMP is Simple Network Management Protocol. We're going to configure our wireless LAN controller to use SNMP in order to forward log messages, known as SNMP traps, to PCA, which will be acting as an SNMP server. This allows us to have a centralized place, which is PCA here, in order to receive messages from network devices and what's happening, as well as pre-configured events. We'll configure that on the wireless LAN controller to send those messages to PCA. Setting up an SNMP server on PCA is outside of the scope of this lab. We have already configured it. It's running in the background. Besides SNMP, we'll also be deploying Radius. That's Remote Authentication Dial-In User Service. This allows us to use authentication and to verify credentials. How is this going to work? Well, instead of having every wireless client sharing the same pre-shared key of Cisco123 as their wireless password, what if each wireless user had their own unique username password combo to gain access to the wireless? Well, they can. We're going to configure the wireless LAN controller to communicate with a Radius server, which will be PCA. PCA will be the centralized location that we will store our users' usernames and password combinations. As our users try to connect to the wireless network on access point 1, they'll be asked for a username password combo. As they type it in, access point 1 will communicate with the wireless LAN controller, and the wireless LAN controller will verify those usernames and passwords are correct with the Radius server. This is awesome. So let's deploy these settings on wireless LAN controller, and this wireless LAN controller is going to be referring to the 172.16.1.0 network where that Radius server resides. The SNMP server is there as well, and the specific IP ends with the .254. So let's configure our wireless LAN controller to communicate with both SNMP to send those SNMP trap messages, as well as Radius to do successful authentication on behalf of our wireless clients. Let's get started. So we're here on our Cisco wireless LAN controller. We're on the main Splash homepage, and we're going to go into Advanced. Inside of Advanced, we're going to jump straight over to Management, and inside of Management, we'll be able to find the settings to deploy SNMP. On the left side, you can see a couple different management services that we can set up. We're going to focus on SNMP at this time. When I click on SNMP, we'll select Trap Receivers. We're going to inform our Cisco wireless LAN controller of the IP address of our SNMP server running on PCA. To do that, I'll click New, and then I can type in the community name that we will use, CCNA v7. Then I'll type in the IP address of PCA, which is running as the SNMP server. And now when I click Apply, this allows my wireless LAN controller to send SNMP trap messages over to PCA, which will then be collecting them. Now, besides SNMP, we'd also like to deploy some security authentication protocol here, and that's going to be Radius. We want to use the Radius protocol in order to have our users' usernames and password combos be sent over and verified on PCA running as a Radius server. That'll be under Security. We will find Radius, and inside of Radius, we will go to Authentication. Now, we have the section for Radius Authentication Servers, and it is blank down below. So let's click New, and we will create a new entry for a Radius Authentication Server. Server IP address is again PCA. That's 172.16.1.254. The shared secret is a secret key that must match on both the Radius server, PCA, and us for the wireless LAN controller. The shared secret allows the Radius server to be able to successfully verify that the wireless LAN controller should be sending username and password combinations against its database on PCA. For that, it has to be the same on both sides, which is testing123. And we type it in twice just to make sure it's correct. Down below, we can leave the default settings here for our Radius Authentication server. We've got the IP address, we've got the shared secret key, and I can click Apply. It is important for us to verify that the Cisco wireless LAN controller can successfully reach the Radius server in order to send these requests of credentials against it. I can scroll over to the side, and here's a little blue drop down, and I can click on Ping. and this will send an ICMP message from the wireless LAN controller over to the server at 172.16.1.254, which is PCA. We've sent 3, we've received 3, we've got 100% success. So at this time, our wireless LAN controller can send SNMP trap messages over to the SNMP server on PCA, as well as our wireless LAN controller can send username, password combinations using Radius from the wireless LAN controller over to PCA to verify users' credentials before they are allowed to join the wireless network.
All right, so that's regarding define SNMP and Radius server on the wireless LAN controller. Okay, SNMP and Radius. PCA is a running simple network management protocol SNMP and remote authentication dial-in user service Radius, server software. The network administrator wants the wireless LAN controller to forward all SNMP log messages, in example traps, to the SNMP server. So the network administrator wants to use the Radius server for authentication, authorization, and also accounting. Means AAA service, AAA services. User will enter their username, password, credentials, which will be verified by the Radius server. The Radius server is required for wireless LAN that are using WPA2 or version 2 enterprise authentication. So not SNMP server and Radius server configuration is beyond the scope of this module. So configure SNMP server information. To enable the SNMP and configure settings, click the Management tab to access a variety of management features. Click SNMP to expand the submenus. Click Trap Receivers. Click New to configure a new SNMP trap receiver. So enter the SNMP community name and the IP address, IPv4 or IPv6 for the SNMP server, then click Apply. The wireless LAN controller will now forward SNMP log messages to the SNMP server. So configure Radius server information. To configure the wireless LAN controller with the Radius server information, first click Security, second click Radius, third click Authentication, fourth click New to add PCA as the Radius server. Enter IP address for the PCA and share a secret that will be used between the wireless LAN controller and the Radius server, then click Apply. Okay. So after clicking Apply, the list of configured Radius authentication server refreshes with the new server listed. So this again another video regarding configuring a wireless LAN for a new wireless LAN. Sorry, create a VLAN for a new wireless LAN.
Hello everyone, we are here to deploy a virtual interface on our wireless LAN controller. But why are we doing it? Well, what it comes down to is every single wireless local area network that we deploy using our wireless LAN controller, those wireless local area networks need their own virtual interface. A virtual interface would be an interface VLAN. But first, let's take a quick peek at the physical view of our wireless LAN controller. We have 5 ports for data traffic, the blue one followed by the 4 yellow. Each of these physical ports can be configured to support multiple wireless local area networks. It would be done by us taking our virtual interfaces that we deploy, and we'd map that virtual interface to be used by physical ports. And these physical ports can even be bundled or aggregated to create larger high bandwidth links. So let's take a look at our topology again, and then we'll get started in the config. So in our topology, what you'll see is we're going to have VLAN 5. And VLAN 5 is going to be a data VLAN, which is going to be mapped to a wireless local area network that's in use on our wireless LAN controller. Then that VLAN 5 network will be able to be routed by our router R1, which is going to have IP address 192.168.5.1 on it. As users join the wireless network that's associated with interface VLAN 5, those users will be placed on the VLAN 5 network. So let's get started in deploying this. So it's time for us to configure our wireless LAN controller with the new interface VLAN so we can have a VLAN 5 network up and running. So to get started, I'm going to go into my Advanced button here. And inside of Advanced, we're going to go over to Controller. And when I get into Controller, we're going to go to the Interfaces section. So when I click on Interfaces, we'll get a list of all of the interfaces running inside of my wireless LAN controller. Right now, we're configuring the controller on the management interface at 200.254. I want to create a new virtual interface for VLAN 5 so I can have user data move through a VLAN 5 network with a new wireless local area network. So to get started, I'll scroll over to the right. I'm going to click on New for a new interface. It asks me for an interface name. I'm going to keep this simple. I'm going to call it VLAN 5 underscore user data. And it asks me for the VLAN ID number, which will be 5. When I click Apply, we're not done. We get a lot of options that'll pop up. So now I need to fill in some information. One of the first things I need to set is the port number. For the port number, this is going to be the physical port on my wireless LAN controller. We're using port 1 out of our 5 ports. Also, it wants an IP address, and this is going to be the IP address of the wireless LAN controller on this network. If we go back to our topology, we'll see that we should have the 5.254 IP address on the wireless LAN controller, and the router will be using 192.168.5.1. So on the wireless LAN controller, I will put in the IP address of 192.168.5.254. That net mask or subnet mask is a /24, which is a class C. The gateway is going to be the router's IP address, which is the exit point for the VLAN 5 network. So I'll put in 5.1 for the router. I don't have IPv6 addressing info, but as clients do come in on the wireless network and join onto network 5, this network should have a DHCP server, and that'll be router R1. It's going to provide DHCP services for the local network. Now, a wireless LAN controller can be a DHCP server, but there's only a specific reason for that, and that's usually to give IP addresses to the access points themselves, and only the access points. That's for management purposes. So there's nothing else for me to configure on this screen. We are good to go to hit apply, and I'll do that in the top right corner. Get a little pop-up for a warning. We'll click OK, and our VLAN 5 user data interface is now deployed on our wireless LAN controller. And this is that virtual interface. So I'm not completely done yet, because the virtual interface exists, but now I need to map it to a wireless local area network. So I'm going to go into my wireless LANs, and inside of here I'll find my user data Wi-Fi. I'll click on that wireless, which is the number 2 ID. And inside of here there's a drop-down for interface and interface group. Right now this is putting users on the management network. But if I click that drop-down, now I can select that new interface VLAN 5 and have it mapped to the user data Wi-Fi. As my users join the user data Wi-Fi wireless network, they'll be put on the VLAN 5 network. And apply makes it happen.
All right. Okay. Right. Topology with VLAN 5 addressing. So each wireless LAN configured on the wireless LAN controller needs its own virtual interface. Yeah. So the wireless LAN controller has 5 physical data ports that can be configured to support multiple wireless LAN and virtual interface. The new wireless LAN will use interface VLAN 5, and then network IP is 192.168.5.0/24, and therefore R1 has been configured for VLAN 5 as shown in the topology and shown in the IP interface brief output. Yeah. So configure a new interface. So VLAN interface configuration on wireless LAN controller, yeah, include the following step. First, create new interface. Next, configure the wireless LAN name and ID. Next, configure the port and interface address. Next, configure the DHCP server address. Next, apply and confirm. Finally, verify interfaces. So configure a new interface. Create a new interface, click controller, interface, and choose new. Yeah. So as shown in this diagram. So next, configure the VLAN name and ID. In the example, the new interface is named VLAN 5, and then the VLAN ID is 5, and apply. So configure the port and interface address. On the interface edit page, configure the physical port number. In example, voice LAN controller G1 interface is port 1 on the WLC or wireless controller. So the VLAN 5 addressing example 192.168.5.25/24, and the default gateway is 192.168.5.1. So next, configure the DHCP server address. The example configure, yeah, primary DHCP server at IPv4 address 192.168.5.1, which is the default gateway router address, which is enabled as a DHCP server. So next, apply and confirm. Scroll to the top and click apply, and then click OK for the warning message. So verify interfaces. So click interfaces to verify that the new VLAN interface is shown in the list of interfaces with its IPv4 address. So next, configure a DHCP server video. All right.
Hello everyone, I hope you're ready. We are here to deploy a DHCP scope on the wireless LAN controller. DHCP? I thought that was on the router. Well, we're going to deploy a DHCP scope, which is very similar to a DHCP pool, but we're going to do this on the wireless LAN controller. And we're going to do this because we want to provide management IP addressing to management devices using DHCP, all controlled from the WLC. Now, this is a specific use here. We're going to provide IP addressing to management devices. We're talking access points that are joining our wireless LAN controller, and we're talking possibly a management PC that would be used to configure the wireless LAN controller. So let's get started. Just a quick reminder here as we get started in configuring the wireless LAN controller, but we are going to be configuring a DHCP scope, not for providing hundreds of users IP addressing. We're creating a DHCP scope to provide dynamic addressing to management devices on the management network, which includes a management machine, as well as our lightweight access points that'll be joining with our controller. So let's get started. We're going to go into the advanced section first. When I click on advanced, we'll have our new screen come up. And inside of this area, we're going to go into controller. Within controller, on the left side, we're going to look for the internal DHCP server. And again, this is very similar to a DHCP pool on a router. DHCP scope looks just like a DHCP pool. I'll click on DHCP scope, and we'll see we're going to have an address pool, lease time, and some other info. Let's get started by clicking New, and you'll give ourselves a scope name, such as management_IPs. That's a beautiful name for management purposes. With the name of management IPs, I can click on that name I've created. It'll load a new screen for me to fill out all the information regarding my DHCP scope. We're going to begin with the pool start address, and this is going to be the first IP address that I'm going to have my DHCP service provide on this management subnet. And that'll be 192.168.200.220. This is the first IP address I'd like to provide on this management network by using this DHCP scope. And the last IP address would be the pool end address. I'll make that 192.168.200.240. In all, I'll be providing up to 20 IP addresses using this management scope. It allows me to deploy up to 20 lightweight access points or a dozen and then some other IPs for management purposes. The network itself is 192.168.200.0, and the subnet mask for this management network is all 255s ending with a .0. The least time we leave at the default. The default router is the exit point for the network. That is not us on 200.254. We're a controller. The exit point is going to be the router's IP address, which is router R1, which is 192.168.200.1. Our scope is good. We need to just enable this. So we'll change the status from disabled to enabled, and we can go ahead and click apply. Our scope is now created on the wireless LAN controller, ready to be allocated to a new wireless local area network.
All right. Okay. So that's a video regarding configuring the HCP scope. Okay, next. Configure the HCP scope.